Let's move on to the simulation of various algorithms and procedures at the data link layer. Let's recall how we simulated ARP protocol behavior when we looked at the design tour of INET. In this module, we shall recall that, and in addition, we should look at what are the variants of ARP, how do they differ in their operation, and what is going to be the impact of their difference of operation on their performance. We had looked at this scenario in which we have a client PC that wants to connect to the server using this multi-hop environment. So as you can see, if the client opens a TCP session with the server, it has to use ARP protocol because ARP helps it to learn the MAC address of the default router 1, which subsequently forwards its connection with the server through rest of the routers. Here we looked at the ARP test client file, and we agreed that the module output is going to be, when we run the simulation seen on the previous slide, that there's an event number, there's a time, and then the type of the module output, which is ARP. And it is looking for the destination address 10.0.0.1, and the ARP protocol is basically broadcasting this request. The ARP broadcast message would contain this information, that is, the destination MAC address is looked for, the source MAC address is this, the destination IP address looked for is that of the server. If you remember, the ARP packet class is actually derived from .msg file. This ARP packet actually is appended with the broadcast address as the control information, and it contains all the information that we have just seen. The IP packet, which is to be forwarded from this client to the server, is enqueued in the input queue of the sending computer till the ARP request is served through ARP reply. When the ARP reply is served, the contents of ARP cache are updated, and we also know that the ARP cache buildup is temporary. It runs a soft timer which has a typical value of 20 minutes or 2 hours. That is all we knew from our previous understanding of the design tour of INET. Now, if you want to simulate ARP with its variants, let's look at the default behavior. The default behavior of ARP is the request is broadcast in nature, but the reply is unicast. The basic ARP works if both the sender and the destination are on the same LAN segment. If the ARP request is being made for a destination which is not on the same LAN segment, then proxy ARP is used. The example that we have seen is based on proxy ARP. Another interesting variant of ARP is the gratis or gratuitous ARP, in which the primary and secondary server are both providing fail-safe service to the clients. If the primary server goes down, then the secondary server uses gratis route reply to the ARP gratis ARP reply to the ARP request made. And finally, reverse ARP is a bootstrapping mechanism that provides IP address to the request which contains the MAC address. RARP is similar to bootp, and its behavior is determined by how network initialization takes place with various configurations.